Class, I will be teaching you today about airships and how gas laws affect them. Now, I don't have too much time, so I'm not going to ramble that much. So I'm going to go straight to the first question. There are three kinds of airships that have been manufactured: blimps, hot air balloons, and what I believe are dirigibles. It could be dirigibles. I don't really know how to say that, so I'm going to stick with dirigibles. Now, to save time, I will not be reading each question. I will just be answering them. Here I go. A blimp is a non-rigid airship. It has no internal structure besides helium. Helium is lighter than air, therefore it lifts up in air. So a blimp is basically a big balloon filled with helium, has a little pit underneath to hold people or cargo, and this was lifted up into the air. Now, a dirigible is the same thing, only it can be a rigid airship, meaning that if it's deflated, it keeps its structure. Now, both a dirigible and a blimp can change direction. A hot air balloon is not filled with helium, it is just filled with hot air. Hot air is lighter than cool air, so therefore it lifts. Now, hot air balloons have to be huge. They're filled with a lot of hot air. For example, in order to lift 1,000 pounds, you would need 65,000 cubic feet of hot air to lift the balloon. To keep the balloon in the air, hot air must be shot up through the balloon using the burner. There's probably an arrow pointing to it. To go in a certain direction, the pilot simply descends or ascends to a level where the balloon can ride the wind in that direction. How are they similar? The Zeppelin is an example of a very famous airship. The name Zeppelin comes from its German creator, Count Ferdinand von Zeppelin. Modern airships are filled with helium. They are not filled with hydrogen. Hydrogen is a very flammable and very reactive gas. It does not have all of its valence electrons, as you should see here, and it is very reactive, and it burns very, very easy, very flammable. Now, the Hindenburg, a very famous airship, belonged to Germany at the time. It was designed to be filled with helium, but since helium was rare and hard to come by, they could not get any helium. America had some, but they didn't want to sell it to Germany because Germany was being ruled by a not-so-nice guy. Now, the Hindenburg was filled with hydrogen instead. This was very dangerous, and it led to its demise. Avogadro states that two gases with the same volume, temperature, and pressure contain the same number of molecules. Each gas has a different molarity, though. So even if there's an equal number of molecules, one gas will weigh more than the other. Therefore, hydrogen is lighter than helium. The very famous airship known as the Hindenburg, the German airship, unfortunately ended in a fiery explosion. Now, this is because of its flammable hydrogen, but a myth arose claiming that the doping solution used to cover the airship's fabric, also known as paint, is what caused the disaster. Now, this is thought because the solution contains aluminum powder, which is a component in rocket fuel, but this material was actually chosen because of its low flammability. Now, the myth was disproved many times, and by many groups, including the famous TV show Mythbusters. This is the formula for the paint, and this is the formula for the reaction. It is an exothermic reaction, and it releases energy, fire. Addison Bain, a NASA scientist, televised his demonstration of the extreme flammability of the Hindenburg skin, and he explained how when a piece of the skin should have self-extinguished after leaving the densest part of the hydrogen near the ship, but instead it would continue to burn brightly. On modern U.S. space shuttles, the powder is mixed with ammonium perchlorate to fuel the rocket boosters on the shuttle while it launches. Hot air balloons are filled with hot air, not helium. Now, they are not steerable, so it's harder for the pilot to move around. To ascend, the pilot will use the burner and thrust heat into the envelope, or this big balloon. That will cause the hot air balloon to rise. To descend, the pilot will simply open up this flap, which causes hot air to leave, and with less hot air, or in other words, with less lighter than air gas, the balloon will descend. Now, to go in a certain direction, the pilot must catch a wind current blowing in the direction he wants to go. So if he wishes to go west, he must ascend or descend to a current blowing west and ride it west. A French chemist, Joseph Gay-Lussac, a very famous man, or a scientist, made the formula P1 over T1 equals P2 over T2. If temperature goes up, so does pressure, and volume and moles stay constant. Testing hot air balloons in the early 1800s, Gay-Lussac learned that equal volumes of gas expand at the same rate as temperature expands. An airplane typically cruises at an altitude of 30,000 feet. Now, it is a very common myth that if it depressurizes suddenly, it explodes. Well, it does not, or at least it usually doesn't. What does happen, though, is since the pressure goes down, we know that the temperature goes down, so it gets very cold, and you can die of hypothermia, or loss of oxygen, whichever comes first. It doesn't really matter. Now, that is the end of this presentation. I hope you enjoyed it. I hope I answered all the questions clearly, and hopefully it didn't take too long. Wonderful.